Hello everyone and welcome to another AP Computer Science video. Today we're moving on to a new subject that's extremely important. This is kind of a big step forward in making programs more flexible and robust in what they do. Everything we've done to this point has been dealing with basic data and functionality in a simple way, but we've been limited in how we can interact with information. We really haven't made any decisions, right? Math is done. Maybe some logical statements may be interpreted, but that's pretty much it. It's kind of a linear progression of a program, which is fine, but complex programs that do all the things that we expect need much more flexibility in how they interact with information and do things, and have to have the ability to make decisions. And so our first big step here is to talk about how a programming language expresses something that we do all the time as human beings, right? We talked about how we follow logical thought processes and use the logical operators to make decisions. So my example was, deciding if I need to take an umbrella or not because it might rain or not. Those are decisions that have to be made, and so now how can we express the same kind of question, maybe based on the data that we have access to, so numbers and characters and strings and Boolean values, but have our program make a decision and maybe run one piece of code or another, but not necessarily both. And this is a very, very big deal. So we're going to make a new package. So all the notes that we have are in the basics package. These are kind of common things enough to get started. And so this next package we're going to create, I'm going to call control structures. These are going to be what we're going to learn here, what we're going to put in this package is the part of the language that lets us control the flow of a program along with the functionality. This enhances functionality. It allows us to manipulate data in a much more meaningful way and control the flow of a program beyond the typical linear kind of one step at a time situation that we've had so far. So I'm going to right click on my project, either in source packages or on the actual project name, and I'm going to say new Java package, which is that little paper box, and this package I'm going to call control structures. Packages don't have to be capitalized. The standard is typically all lowercase, so I'm just going to call it control structures. And there it is as an empty box, and now we can put some classes inside of here. So the next couple classes that we'll see in videos will probably be in this section. And so I'm going to go ahead and make a new Java class, and we're going to call it conditional statements. And so there we are. We'll start off by making a main like we typically do. I'll use a shortcut. And there it is. So what is a conditional statement? And you may have heard this, and if you've done any programming, you've definitely heard the term, or if you haven't heard the term, you might have heard if statements. Whenever we ask a question to make a decision that has a yes or no answer or a true or false answer, these are if statements or if questions, and in programming languages they're often called conditional statements or conditional structures. These are the idea is that some condition is evaluated, and whether or not it is true or false, some piece of code will either run or not run, or will choose between two sections of code, or potentially choose between many different paths of code. But that flexibility, that control, is through a conditional statement. So let's go ahead and write some notes. We'll say conditional controls the flow of a program by evaluating one or more conditions that Boolean value. And so the first type of conditional statement we're going to talk about is an if statement. So I'm going to go ahead and put if statement. Asks or evaluates a Boolean expression. And a Boolean expression is just any expression, simple or complex, that results in a true or false. So a comparison with a relational operator, maybe the mixing of many logical operators, or arithmetic with relational and logical operators, anything you could imagine, or maybe just a plain Boolean variable, anything that evaluates the Boolean. The expression as simple as a single variable can be used in an if statement. So it evaluates a Boolean expression, and if expression is true, the code inside of the if statement. I don't have quotes. This statement. Body. I put body in quotes because it just means a set of curly braces will run. So we'll start with a very simple example. let's go ahead and make a variable. So I'm going to use an int because it's kind of simple. We'll say int num, and I'll start off by giving it a typical value, just anything. I'll hard code it, and then maybe we'll change it to be random so we can see the effect. And so I have a num, and I'm going to say, well, based on what this number is, I may want to print some message. So for example, if. And so now the structure is always going to be, and I'll write it in notes so we always have the format. So the format is if, and then a set of parentheses, and in the parentheses we have a Boolean expression, whatever that might be. It could be very simple or very complex, but it must evaluate to Boolean. And then we have our body that is represented by a set of curly braces, and then within those curly braces we may have some code. So 0 or more lines, typically not 0, but technically we're allowed to have 0 or more lines of code inside the body. And what we're saying in this statement is we're saying if this expression evaluates to true, then we run whatever code is inside of it, and if it is not, then we skip past it. So these curly braces signify the body, meaning the chunk of code that may or may not run. And this is a very powerful tool because we can essentially skip pieces of code or do extra code when some statement is determined to be true or false. So in our example, we might say, well, if the number is below 15, then we want to print out a message, and if it's above 15 or equal to 15, we do not want to print out a message. So I'm going to say if num is less than or equal to 15, and then here's my body. And so again, this statement is a very simple one, and it's either a true or false, and in this case it will be true because 10 is less than or equal to 15. We can do something like print out a message. Right, so this is the smallest number. So if I run this program, we expect to see this message. The program flow is still essentially linear. It says, okay, well, create a variable, assign it a value 10, ask the question, is that number less than or equal to 15? And if so, it is, print out this message. So now let's go ahead and change this number. Let's change it to number 17. If I run it, we can see in this case nothing printed. The program basically ran and it ended immediately. There was no visual result because this was a false statement, and if the condition of this if statement is false, the body is skipped. So the program hits line 13, it hits line 21, it's false, it jumps immediately to line 25 and then ends. So that's a very simple kind of boring program. Let's go ahead and try making this a little more interesting. Let's make this a random number. So instead of being 17, let's do something like we'll cast to int and we'll say math.random times 50, actually 45 plus 5. And so, or actually let's do 46. So 46 plus 5, this tells us this is a range between 5 and 50. Because if we do the lower bound possibility, random is 0, 0 times 46 is 0, 0 plus 5 is 5, 5 as an int is 5, so the lower bound is 5. That's the lowest possibility. The upper bound, random, would give us 0.9 repeating. 0.9 repeating times 46 would be 45 times 0.9 repeating. 45.9 repeating plus 5 is 50.9 repeating. 50.9 repeating cast to an int is 50. So the upper bound would be the integer 50. So we'll get whole numbers between 5 and 50. And so the question is, there are more numbers above 15 in that range than below. So we should more often not see any output. But because it is random, we should eventually see some input because a number will eventually be below 15. So let's try running it a couple times. First time we saw nothing, so it must have been above 15. Let's run it again. Still above 15. Still above 15. Still above 15. Still above 15. Now, did I make a mistake, or is it just a giant coincidence? It seems more and more likely that I may have made a mistake, because for it to not hit a number below 15 seems... but there it is. So it wasn't a mistake. It was just I had an unlucky streak of getting larger numbers, but there it is. And so a conditional statement essentially splits it. So if I were to draw, I'm going to draw a representation of what an if statement is. What would it look like? So I have my little whiteboard here, and what I'll say is, if our program flow is a line, the program is running line by line, line by line by line, and then it hits a question. And the way we're going to express a question in our little diagram here is we're going to put like a diamond. And so our question is what? Is num less than or equal to 15? And there are two possibilities. If it's true, then we may run some code and continue. And if it's false, then we're going to do nothing and move on. So this is when it's true. And this is when it's false. So when it's true, our code is what? Our system.out.print and or whatever our message happens to be. And if it's false, we just move along. So now suddenly we have two paths to take. So the program runs, it hits the if statement, asks its question, the Boolean expression is evaluated, and if it's true, it comes along and does this body. This body is between the curly braces. There's the open and there's the close of the if statement. And then once it's done, it moves on to the next line and kind of joins back into that linear program and continues. If it was false, then this is as if this path was never seen and we just went right along to the next line. And so if the next line down here was a second print, then this print is guaranteed to happen, but this print is conditional. It only prints on the condition that the Boolean expression evaluates to true. So if we go back to our program, we can try something like that. We can say, you know what? We'll print out the number is, and let's go and attach whatever num was. So now we can kind of see, we're always going to see the number, but we're not going to always see the message. So it was 22. It was 5, and there we see the message and the print of what number is. If we run it again, it's 29, we don't see that first message. So this is kind of a potential path to take, but it's not guaranteed, right? And so it is a conditional statement because only it's only possible in certain conditions. So this is one version of a conditional statement. We're going to do the next version, which is a little bit more control, but it has a very specific scenario, and so it's not always necessarily the best option to have. And I'll mention there are no limits to the number of if statements you can have one after the other. So you can ask 7 conditional statements, and they may or may not be true. All 7 could be true, so you could potentially see 7 numbers or 7 statements. You might see none. You might see 1. You might see 6. There's no limit. So let's actually write a second one real quick. Let's do something like, well, if the number is even. So if the modulus by 2 is 0, because if any number is divisible by 2, the remainder would be 0, which would imply that it is an even number. So let's say if the number is even, then let's print out that message. We'll say system.out, and we'll say this number is even. And so now we're going to run our program, and we should see 35. Notice we saw neither statement. Why? Because it was not below 15. So this was false, so we skipped to the next available line, which is 25, another if statement. And 35 is not divisible by 2, so we didn't get a remainder of 0. So it skips past that, and then we see the only statement we see is the output of 35. So let's go and run it again and see if we can get another number. So 18, we saw the second one. So these if statements are not mutually exclusive. This means that they can both be true, one of them can be true, or neither of them can be true. It's any of them are possible. They're completely individual statements, right? And so let's go ahead and run it one more time just to see if we can get a number below. So 29, 12, perfect. It's a small number and it is an even number. So we've seen that scenario. And then number 19. And then now let's get a number, let's see if we can get a number below 15 that is not even. So that's odd and above. That's above and 16, so let's get one 10 and even, so let's see if we can get an odd number under 15. Nope, still even. 37, 23. Oof. Yeah, see, our range is pretty big, so it's unlikely we have to run it a bunch of times to get low numbers. Up, still even. Well, let's do that. Just want to show you that all 4 possibilities can happen. So I might have to give up soon. I don't want to keep running this too often. 25. Let's do 1 or 2 more. 10 is even. That was unlucky. 41. Let's do 1 more. And I'm going to give up. But the idea is that there are 4 possibilities because both statements can be true. One can be true and not the other. The second one can be true and not the first one, or both can be false. And we've seen 3 out of those 4 scenarios, but it is definitely possible to get that 4th scenario. So let's go ahead and write down our second if statement, or second conditional statement, and we'll call this an if-else statement. So an if-else statement is basically the same as an if statement, but now instead of being you take an extra path and come back to the original, or you just skip the extra path, now we're kind of making a fork in the road in our program. It's not possible to avoid one or the other. You can pick one path, and in fact, it's much more strict in that only one of two paths may be selected. So either you go through the true path or you go through the false path. So we'll draw a diagram in a moment to see what this looks like, but this is a pretty big deal. So we'll say, similar to the one above, evaluates a Boolean expression, and if the expression is true, the if body is run, otherwise the else body is run. So now there are not single questions, but it's a question where you either get a yes or no, and based on whether you get a yes or no, you get one set of code or another. And this is a pretty important thing to happen. So let's do an example. We'll say something like, if the number is below 50, then, well, I would do maybe like a passing grade, right? Anything below, we'll say anything below a 70 is failing, anything above a 70 is passing, right? And so the range doesn't really matter. It's just an arbitrary example. So we'll say our number is equal to a random number, random, and we'll say between 0 and 100 inclusive. So we'll put 101, which is a range of grades that most students can get, right? Between 0, you can potentially get a 0, and up to a 100 as a high score, we're assuming no extra credit. Right, so that's 0 to 100 inclusive as an integer. So now let's ask a question. Let's say, well, if the number is less than a 70, then we're going to print out, let's see, better look next time. And now here's the second part. We'll say else. We'll put our curly braces, and now we can do a second message, and we'll say, congrats. Right? And so I didn't put the layout, but let's go ahead and put the layout, and I'll just write it real quickly. We have our if, our Boolean expression, with inside our parentheses. Oops, did not need to do that. We have our curly brace for our body. We have the code, whatever code happens to be in here. So that's whatever code. We have our closed curly brace for the body. And then afterwards, we have an else keyword. So else is now a keyword, and it also has its own body. And that may be multiple lines of code, or one line, or any number of lines, right? 0 or more lines. And so both of these have their own bodies, and the important thing to note is that only one of these sections will run. This is called mutual exclusion. If one is done, the second one is not. If the second one is done, the first one is not. They cannot both be done. And so let's draw, before we run this, let's draw a diagram to represent what is happening here. So this is the diagram for an if statement. Let's go ahead and clear it and try a new one. So here in our situation, it's a little bit different. Our program is coming down in this linear fashion. We hit an if statement, we ask a question. And so in this case, we'll say what, num less than 70, whatever that number happens to be. So now the situation is this. In one route, if it's true, we go left and we do the if statement body. And then we come back to our program. Oops, didn't do that. Come back to our program and we go. And in the second situation, the evaluation is false, and we run a second body of code, potentially. And then we come back to kind of the main point of the program and continue on in this. So in this case, the statement is true. In this case, the statement is false. It is not possible to both be true and false at the same time. So here you will run some code, whatever that code may be, or you will run this code. So this is code A, and this is code B, right? The reality is only one section is going to run. It's not possible to be true and false, so you'll only see A or B, but never both, right? And so this is an important idea because these are mutually exclusive paths. You will never see both chunks of code run. And so when you make an if statement, you must decide, is it appropriate to use an if-else or just an if statement? Do I need to enforce this idea of only one thing or another, but not both? Right? If we could do the same thing, the same blocks of code with A and B, but put them in two individual if statements, and the potential would be that both A and B could run. So I'm going to draw a diagram on the side here that would show potentially what that might look like. So I'm going to do this kind of in a smaller fashion. So this is one statement. So let's say this is code A, and we would continue here, and then what would happen is a second question would occur, and then or we would come here, and then this would continue. So this would be code B. So in this case, we have two if statements. So this is an if, and this is an if. But in this case, this is true or false. Let's say they were both true. They were both going to be true, right? So that the statement is less than 70, then A would happen. So code A would run, and then we continue. And then this is also true, and then this code would run. In this situation, it's only possible to be true or false. And if it's true, you're going to run A, and you're never going to see B run. If it's false, you will never see B run. In this case, let's say the first one was false, then you would only see B, or if the second one was false, then you might only see A, or if they were both false, you would just kind of go down the straight line and you would see neither, right? The idea is that in this case, both of them can happen, one of them can happen, or neither can happen. In this situation, one of them is going to happen based on our condition. Right? So this is a much more powerful, it's a different scenario. There is not a right answer, always do one or the other. It depends on the context of what you were trying to express. And this is why it's important, because we might do this instinctually. We might kind of, as humans, understand when someone's trying to be strict in their definition and mutually exclusive, and loose in saying, oh, as long as it's one, I'm okay. But a computer can't do that. It cannot assume what we can, or is not intelligent enough to make an educated guess like we can. And so therefore, we must be explicit about how we want the computer to interpret what it's going to do. So let's test out our if-else code and see what happens. So let's actually go ahead and print out our grade real quick and see that happen. So let's print out our message. Our grade was bin, whatever none happens to be. So here we go. We're going to run it. It was a 26, so we got better luck next time. It's a pretty rough grade. And again, this was true, and so the code says, okay, run the body of the if, and then immediately skip the else. Don't even look at the code. Don't bother. It's not necessary. It jumps right past it. Let's run it again. An 86. So in this case, it printed out an 86. 86 is not less than 70, so this is false. So we skip this body. So we don't look at line 51. We go immediately to line 53. And then in an else, we automatically go inside and print out what's inside. In this case, congrats. Something else to note is an else does not have a condition, because the condition is implicit, meaning if this condition is not true, then the opposite of this must be true. So by saying it's not less than 70, what we're implying is that it must be greater than or equal to 70. If you say if it's less than 70, that would be every number from 69 all the way to negative infinity, right? That means it will cover every number below it. But if you're not in that case, if that was a false, then the else must cover 70 to positive infinity, right? And so the else is kind of like a catch-all. In the worst case scenario, if the statement is not true, then we're doing the else, right? And so we have to be very clear about what our question actually is. Do I include 70 or not? Well, that would tell us whether we use an equal sign or not in our comparison, right? And so it's important that those distinctions are clear. The opposite of less than is not greater than. The opposite of less than is greater than or equal to. The opposite of less than or equal to is greater than, right? So we have to be very clear about that. And if we drew a number line, it would maybe be more apparent. But I don't think it's necessary, because it is a pretty simple comparison to make. So I'm going to stop this video here. We'll continue in another video with a little bit more complexity. There's one final version, which is kind of the ultimate version of an if-else statement, and it allows us to do even more. But essentially boils down to this idea of splitting and choosing a path. And this is kind of a useful scenario. So I'm going to stop here, and I'll see you in the next video.